Alright, good morning. So in 5.4 we're going to start looking at factoring. There's a lot of different ways to factor. The first way we're going to look at is just taking out a greatest common factor. The idea is basically the opposite of the distributive property. So for example, if we had like 3 times x squared plus x plus 2, and we distributed the 3 through, we would have 3x squared plus 3x plus 6. Well, basically what we're going to be doing is starting here and going backwards. So we would be factoring out this 3 because that is the greatest common factor between these 3 terms. So what we're going to do first is just practice how to figure out what is the greatest common factor. So in this first example, I've got an 8x and a 24x squared. And so I want to ask myself, what does 8 and 24 have in common? And I know that 24 is the same thing as 8 times 3. And I know that x squared is x times x. And then over here, I have an 8 and an x. So, what do they have in common? They have an 8 in common, and they have an x in common. So that would be the greatest common factor. And we tend to abbreviate it as GCF, greatest common factor. So in this case, the greatest common factor would be 8x. Both terms have that same value. Now, another way someone might do the problem is they might say, okay, well 24 is 4 times 6. And 8 could be written as 4 times 2. And then they might say, oh, 4x is the greatest common factor. But here's the problem. There's a 2 left over here, and there's a 6x left over here. Now 6 could be broken up more into 2 times 3. So really, they did have a 2 in common. So if I multiply that by 2, I'll get an 8x, which is what I got at the beginning. The idea is we're trying to find the greatest, the highest number that they have in common. So out of 8 and 24, the biggest number they have in common is 8. Let's try another one. Okay, so here we want to figure out what does 21 and negative 30 have in common. So it looks like probably 3. 21 can be written as 3 times 7. Negative 30, x to the third, could be written as 3 times negative 10 times x times x times x. So it looks like the only thing they have in common is that 3. So the greatest common factor is just a 3 in this problem. Okay, now what we're going to do is find the greatest common factor, and then we're going to factor it out. So now it's going to be like the opposite of the distributive property. So this is the expression right here that we're going to be factoring. And what I've done is I've just broken each term up, and we're going to look at them separately. So I would write out the different factors, the different multiples of 25x to the 5th. So I would write it as 5 times 5, and then I would have 5x's. And then here, 20 I could write as 5 times 4. And then I've got 4 x's. And then here, 5 also goes into negative 30, negative 6 times. And then I would have 3 x's. That's multiplication, that's a negative. So, what do they have in common? Well, they all have a 5 in common. And how many x's do they have in common? This has 3 x's. This one has 3 x's. This one has 3 x's. So what they have in common is 5 x to the third. So now, if we're going to factor that term out, we have to figure out, well, what are the leftovers? So in the first term, there is, hang on a second, there is a 5 and 2 x's left over. So that would be a 5x squared. In the second term, there's 4 and 1x left over, and that's a positive 4. So we write plus 4 and then that x. And then in the last term, there's just a negative 6 left over. So what we've done is we've looked at all of these terms and basically factored out, pulled out what they have in common. 5x to the third is what they have in common. So 5x to the third is the greatest common factor. And then the stuff in blue is the leftovers. Now, if you ever want to check your work to see if you did it right, I'll do it down here. You could always just distribute back through and see if you get the original problem. So if I distribute that, I would get 25, and then x to the third times x squared is x to the fifth. And then here, 5 times 4 is 20. X to the third times x is x to the fourth. And then 5 times negative 6 is negative 30. And then I would have x cubed. And yeah, that's what the original problem was. So we know we did it right. Let's try another one. Okay, so same kind of problem where this is what we are going to factor, and I just broke it up, each term separately, and we're going to look at what do they have in common. So I've got 8s and I've got a 48. Does 8 go into 48? It does. So, whoops. So I'm going to write this as 8 times, and it would be a negative 6 because I need a negative 48, and there's an x. In this problem, I have an 8. It would be times a negative 1 to make it a negative 8. And then I have x squared, so I've got 2 x's multiplied together. And then in the last one over here, I've got an 8, and I have 3 x's multiplied together. All right, now what do they all have in common? They all have an 8, and they all have 1x. So that is the greatest common factor, 8x. Now we're going to look at the leftovers. In the first term, there's x times x, which is x squared. In the second term, there's a negative 1x. And in the last term, there's a negative 6. Those are the leftovers. So this right here is the exact same thing as the original problem. We just factored out the greatest common factor. And again, the greatest common factor was 8x. Okay. Here's another one. Getting a little bit more complicated. But if you list out all the factors, it's going to make it easier. And if you do kind of what I did, where you circle what they have in common, I think that's helpful too. All right, so our numbers, we've got 16, negative 24, and negative 8. And so I want to think of like, what multiples goes into all of those, and I want the biggest one. So like, for example, 4. I know 4 goes into 16, and 4 goes into 24, and 4 goes into 8, but is there anything bigger? Well, 8 is bigger. So 8 goes into -8, 8 goes into -24, 8 goes into 16. We should go with the bigger one. So here I'm going to do 8 times 2, and then I have a to the 5th, and then I have b to the 4th. And then in the middle term, if I break it up, it would be 8 times -3, because I need it to be a -24. I have 2 a's, and I have 5 b's. And then in the last, it would have to be an 8 times -1 in order to make a -8. And then I have 3 a's, and I have 3 b's. Okay, so now we're going to circle all the things they have in common. So they all have an 8 in common. How many a's do they all have in common? Looks like the smallest amount of a's is 2. They all have at least 2 a's. How many b's do they have in common? Looks like 3 b's. So all the stuff in red is an 8 a squared b to the 3rd. And now what we need to do is look at what are our leftovers. So in the first term we have a 2, we have a to the 3rd, and we have a b. In the second term we have a -3, so -3, and we have b squared. And then in the last term we've got a -1 and an a. And that is our final answer. This whole thing. And the greatest common factor in this problem was 8a squared b to the 3rd, because that's what they all have in common. Alright, I think we've got one left. Same thing here. Look at all the numbers, 12, -6, -3, and just kind of think to yourself, what would be the highest number that they all have in common? 3 is the highest number that they all have in common. So I'm going to break them all up with 3. So 12 is 3 times 4, and then I have 2 x's multiplied together and a y. Here would be 3 times -2, and then I have an x and a y. And then this would be a 3 times a -1 times a y. So let's circle what they have in common. They all have a 3 in common. They all have a y in common. So 3y is our greatest common factor. Put parentheses, and now we're going to write out what the leftovers are. So in the first term it's 4x squared. In the middle term it's -2x. And in the last term it's a -1. And that is your final answer. So that's all you're going to be working on today. Your homework is in the book. You can work on that for the rest of the period, and I'll help you if you need any help.